Hey guys, in this video what I'd like to do is I kind of want to talk about electrical theory. And we're going to go ahead and we're going to go all the way down to the atomic structure. We're going to talk about matter, we're going to talk about molecules, and then I'm going to try to apply that to what the electrons or the electron flow theory, so that you can really understand and kind of visualize it in your mind what's happening with electricity. See, the problem is people get very confused when it comes to electricity because they can't see it. It's really easy to see, fluid power because the hydraulic oil is moving through a tube and it's, doing some sort of work at the end. Even mechanical is really easy to understand because we can see an arm come out and push an object, or maybe, a spinning motor. You can see that. It's really easy to see that mechanical force, while electricity is totally different. So what's actually happening inside that wire is the electrons are flowing, and I'm gonna get into this really in detail here in a second. The problem is we can't just cut a wire and actually see electricity flow out of it, because those electrons are actually staying inside that wire. You can kind of see some things like arcing or some sort of like lightning. You can see that electricity, but that's not quite the same thing. So let's go ahead and let's jump right into it, and we're going to start talking about matter. Now, matter, let me go ahead and write this up here. Matter is everything. So everything such as, water, it's going to be rocks, it's going to be you, it's going to be me. Anything that actually takes up space is matter. If we were to go to the smallest particle that still holds a chemical property, those are called molecules. Now, I'm going to go ahead and let's just draw, so it's going to go down. Oops, that's an arrow. I don't know if you can tell it. To molecules. Molecules. Now, a molecule, like I said, is the smallest structure that still maintains the property of this matter. So if the matter we're talking about is, let's say, water, this molecule is still actually water. If we go below that, we're going into elements, and that's where we're going to talk about atoms. But let me go ahead and I want to draw up like what a molecule might look like. This is a really popular one. It's a bunch of atoms or elements linked together to make that molecule. So let's say we took water, because we were kind of started with that one. That one is H2O. All right? So H2O is actually 3 different atoms coming together to make that molecule, which a bunch of those molecules turn into a big body of mass or water. So the atomic structure here is going to be 2 hydrogen atoms, and that's the H stands for, and the 2 and 1 oxygen atom, and that's going to turn into that molecule. Now, this one is not an actual H2O molecule, but it could potentially, they'll sometimes be written here as H, and then you'll have your oxygen, and that'll make up your atom. All right, so moving down, or that'll make up your molecule. So moving down, we're going to go into atoms. So an atom, again, is going to be an element. It's going to be an element, like I said. So that element could be the hydrogen, it could be the oxygen. We're going to talk a lot about copper atoms. We can also have carbon atoms. This is every little thing that can be broke down to the smallest possible atom is that thing. So let's go ahead, I'm going to clean this off, and I want to talk a little bit more about atoms, because that's where it's all really happening, and that's where you guys are really going to be able to picture this electricity. The atom is actually made up of about 4 different things. There's going to be some couple other little things I'm going to add in there, but they're not really important. So all atoms are made up of a nucleus. The nucleus is going to be the center, and I'm going to draw it here in a second. Protons, neutrons, and electrons. Now, before I draw this, I want to talk a little bit about the law of charges. Now, have you guys ever played with a set of magnets, and you took the positive ends and you tried to push them together, and all they wanted to do was push apart? Or maybe you flipped it and actually had a negative going to a positive, and they just wanted to suck together really nice and tight. Well, this is actually kind of a continuation of the law of charges, because those are actually magnets. Those are actually made to be magnetized. Now, electricity actually does a funny thing when electricity is running or there is electricity present. There is a magnetism or a magnetic field around that wire or whatever that electricity is going through or around. So it's safe to say that our atoms are going to have a lot of those same characteristics or have that law of charges working inside of it. So let's go ahead and draw this. So the first thing, like I said, was going to be our nucleus. So we're going to go ahead and I'm just going to take an arrow and we're going to go ahead and point at that. So the nucleus is going to be the center. All atoms have a nucleus. I'll try to draw that a little darker for you. All right. Now the nucleus is going to be made up of those protons and neutrons. Now we're going to go ahead and put these inside here, and I'm going to talk a little bit more. So we're going to label these ones P for for protons and N for neutrons. So I'm just going to go ahead and we're going to point there. Little arrow. This one's going to come over here, and there's going to be an arrow to those ones. Okay. Now our protons are actually going to have a positive charge. We've played with batteries before, and we know that there's a positive and a negative to a battery. So these ones are going to be our positive charge, while our neutrons are actually going to be charge neutral. They're not really going to have any positive or negative. They're just kind of there. Now, one thing I want to point out is that nucleus is not an actual physical thing. It's actually a collection of these protons and neutrons to make up that nucleus. Now, around that nucleus is actually going to be some shells, and this is the part where I'm going to add these in, but they're really not that important. Okay, so there's going to be shells, and I'm just going to kind of go around. We're just going to do some light shells here. I'm going to draw 2 of them, but there's actually going to be about 7. With the last one, or the furthest out one, so this one out here is considered the valence shell. Now, the valence shell is kind of the one that we're most interested in. It's kind of the most popular one. It's what everybody's going to talk about. The other shells are going to have different characteristics, such as how many electrons they hold. So these electrons that we were talking about are going to be going ahead and they're going to be floating around out here. I'm going to try to put an E in all these. And there's going to be spaced all around, okay? So there's a bunch of them. So this is kind of an interesting thing. So I said I was going to talk about copper atoms. So a copper atom has 29 protons here. If it has 29 protons and the atom is in its neutral or natural state, it's going to have 29 electrons. So there's actually going to be 29 electrons spread out throughout all of those shells. Now there's going to be more shells closer to the actual nucleus. And they're going to kind of arrange differently throughout all of those shells. But the most important thing is the valence shell. The valence shell will only have 1 electron in it. And we're going to talk a little bit more about conductors and insulators moving on, but as a quick understanding of what the difference is. So a conductor would be something that electricity can easily pass through, while an insulator would be something that electricity doesn't want to pass through very easily or not at all. What makes the difference is how densely packed these electrons are. So I'm going to draw another picture here with multiple electrons, and I'm going to show you how the electrons will jump from one to one and all the way through that wire. Now, these electrons, like I said, the more dense they are on the atom, the less likely they are to move. So an atom that has 1 or 2 1 or 2 electrons in the valence shell is considered to be a good conductor of electricity. If it has somewhere between 6 to 8 electrons in this outer shell, it's not going to want to move, or it's not going to want to release those electrons very easily, because there's going to be a lot of extra magnetic force. Like I said before, these electrons are negatively charged. So our protons are positive, electrons are negative. So the electrons are actually being pulled to these positive protons. So that's what's kind of keeping them floating around in this area. So what's going to happen is, if there's more of them, those electrons are going to kind of add up, and we're going to talk more about this when we get into our magnetism section. The more electrons, the more magnetic force there is, because they're doubling every time we add an electron, and it's wanting to suck them into that center. So those electrons are not going to want to move very easily. And I'm going to go ahead and draw this arrow while I'm here. There we go. So that's kind of the makeup of an atom. What I want to do is I'm going to clean all this off, and I want to draw a bunch of atoms, and then I want to talk about how the electrons are bumping from one to the next, and they're moving on down. Because these electrons they're electricity. All right, so now I got 4 atoms here. Now, I want you to know that there's millions of atoms that make up a copper wire. So we're going to pretend that these atoms are inside of a copper wire here. And what we're going to do is we're going to talk a little bit more about electron theory flow, okay? So what happens is when we hook up a battery into a system, we're giving it a positive charge. So there's going to be a positive over here, and then we're going to have our negative over here. We're going to talk a little bit more about batteries, and we're going to talk a little bit more about voltage, but right now we're just talking about that electron flow theory. So I've drawn it, and I've tried to color code it a little bit better for you guys. Sorry about the previous one not being color coded. So I've got my atoms, and I've got my electrons, and they're flowing around each atom, or each nucleus. So what happens is the atom in the valence shell, and I didn't draw all the shells, so this is a very simplified version of what's going to happen here. So the electrons are flowing around, and there's this electron, say here, is going to flow around and actually going to hit this electron, causing it to actually break free and break loose. Now, because there's such a high positive charge, it's going to cause it to want to go that direction. This is a little known myth that electricity flows either from positive to negative or negative to positive. Well, actually, electrons are negatively charged, and they're trying to get to the positive. So they're going to be flowing to that positive. I know that kind of breaks everything you've ever heard before, but this is the scientific theory. Well, most of the time what schematics use or what people use is it's actually flowing in the opposite direction, and that is called the Hole theory. We'll maybe explain that a little bit later, but for right now, we're just trying to talk about that electron flow theory. So the electron's trying to get to that positive. And one electron came around, hit this one, and then it becomes loose. So now it does not have an atom it's connected to. Well, this is happening multiple times. They're constantly getting knocked loose and they're becoming free. So this electron may go and get into this valence shell of the next atom. And it could do this same thing over and over again, causing free electrons to constantly be moving forward. Because there's always going to be a little bit of an extra magnetic pull trying to get it to go that direction. So what's going to end up happening is they're flowing around, so they're actually going to be kind of jumping around a little bit like this until they get to where they want. And they could potentially be, going on the opposite side, just constantly moving from atom to atom to atom. Now, this is what they call current. Now, current is also considered amps, is how it's measured. You'll sometimes see it written as I, you'll see it's written as current. You'll also see it written, like I said, as amps. But it's just the flow of these electrons. Now, one thing that's very important, and we're going to talk more about amps as we go along, but the amps is actually measuring how many of these little electrons are flowing towards that positive source. Now, one thing to know is that an amp is not just one electron, it's actually times 10 to the 12th power. I'll have that written here below just so you can get a better idea. But it's a lot of electrons. It's a couple 100,000 makes up 1 amp. So there's a lot of electrons moving here. So, like I said, they're knocking each other off and they're just kind of flowing towards this. Now, one thing that's very important to understand the electron flow theory or electricity, if we were to cut the wire right here, all of a sudden there is no longer a connection. We'll go ahead and draw that as a black here. That wire is now cut. So what's going to happen is either the electrons will be able to jump this gap because there's enough electrical force because there's a battery in that EMF or that voltage is actually pulling it across that gap, or all of a sudden it's now just going to start kind of maintaining right here and it's going to equalize. So all the electricity will just kind of bounce back and forth and it'll go back and forth. So that's why you're going to have 12 volts right here or 12 volts right here, but you're not going to have any electricity flowing. So it's just kind of there, always on standby. So that's our introduction to the electrons and the atoms and the electron flowing and that amps. Now, some of the things I want you to kind of take away from this. One, we're going to take away all the parts of an atom, and we're just going to go over them really quickly. We got our nucleus that makes up the center of that atom. We have our protons and we have our neutrons that are going to be clumped together in the center of that atom. and that's going to create that nucleus. We have our electrons flowing around that atom, just kind of constantly moving in that area. There's going to be multiple shells, but the main one is going to be the valence shell, and the electron in that valence shell are going to be called the valence shell electrons, or the valence electrons. Electron flow theory is going from negative to positive, and mass, it makes up everything. You, me, rocks, water, everything. A molecule is going to be the smallest broke down particle that it still has the same chemical property as that mass. Remember that H2O? So a molecule actually will be water, and then that mass will still be water. What happens after molecules is going to break down into atoms. And remember, atoms are elements. Like I said before, they could be, hydrogen, oxygen, carbon. They can be all those singular elements, and when they come together and make that a molecule, that's when they turn into something. So electricity is happening on that atom level. It's going to happen, and you can't even see it because we can't even see atoms. It's very small, very tiny. So I hope this helped you. If you guys have any questions, or if this was a little bit confusing, I'd love to talk about it. I find this stuff very interesting. Please let me know. Otherwise, go ahead and continue on.